Okay, class. Now we're going to do another example. In this case, we have a story problem, but it's not much of a story. It's a company that is unnamed, has determines production level, and it doesn't tell us what they're producing. It's given by the Cobb-Douglas function of fxy equals 2.5 times x to the 0.45 times y to the 0.55, where x represents the total number of labor hours in 1 year, and Y represents the total capital input for the company. So capital input would be like different technology stuff they've bought to help their laborers work faster. Suppose 1 unit of labor costs $40 and 1 unit of capital costs $50. Use the method of Lagrange multipliers to find the maximum production level subject to a budgetary constraint of $500,000 per year. Okay, so here we're not given the constraint function, we're just given what we need to determine the constraint function. So the constraint function is basically that um, the our budget is set at 500,000 a year, which means that, and then what kind of goes into our budget? Well, we just really have labor and capital, or the stuff or like stuff. And so $40 for each unit of capital, which means 40 times x plus $50 times y is equal to that. If $40 times x plus $50 times y equals that, that means we're we're maxing out the budget. Okay, well, that means that g of xy is basically move everything to one side. It's 40x plus 50y minus 500,000. Okay, well, let's see. That means we need to compute um, the gradient of xy, and that's going to be, well, when we take our derivative with respect to x, then we get 2.5 times 0.45. So it's basically, if I treat these as fractions, it'll be better. So let's rewrite f of x with fractions. F of xy equals 5 over 2 times x to the 0.45 would be 45 over 100, which would basically be 9, wait, 45 over 100 divided by 45 divided by 5 is 9 over 20. And y to the 11 over 20. Okay, so then when I take the derivative with respect to x, then fx of xy is equal to, you kind of multiply by the 9 over 20, which would be 9 over 4 times 5. So you get 9 over the 4 times 5. The 5's cancel out. You're left with 8 times x to the negative 11 over 20, y to the 11 over 20. And then similarly, fy of xy is equal to multiplying by the 11 over 20. We'll get 11 over 8 times x to the 9 over 20 times y to the negative 9 over 20. Okay. 9 over 8 would be 1.1 uh 8, 1.125. All right, so that means we've got it's going to be 1.125 times x to the negative 0.55 times y to the 0.55 I plus 11 over 8, which would be 1 point at a 1/4 to that, so plus 0.25, so 0.375 times x to the 0.45 times y to the negative 0.45 j. And then the gradient of g of xy is, of course, 40i plus 50j, which gives us equations with regard to, so we do our equations with regard to I, that means 1.125 times x to the negative 0.55 times y to the 0.55 equals 40 lambda. And 1.375 x to the 0.45 times y to the negative 0.45 equals 50 lambda. Okay, and then finally, g is equal to 0. So that means that 40x plus 50y equals 500,000. Well, well, well. Let's see here. So, we have our systems of 3 equations, which are not linear, which will make things possibly ugly. But there's nothing to be done except solve for lambda. That's the easiest thing to do, so we will do that. Okay, so basically that fraction, or that decimal 1.125, is really like a 9 over 8. So a 9 over 8 divided by 40 is just not pretty. All right, so we have 1.125 divided by 40 is, oh my. All right, so 0.028125. So, you know what? We don't have to solve for lambda. We could just solve for something like 10 lambda. Or we could even solve for what's the thing they have in common? So if I can multiply that one by 5, that one by 4. So instead, if I take this equation and multiply it times 5 in this equation and do it times 4, then I'll end up with 200 lambda on the right side of the equation. And then I can set the things equal, and I have less ridiculous decimals to deal with. Okay, so 1.125 times 5, that's going to be 5.625. So 5.625 x to the negative 0.55 y to the 0.55 equals, and then 1.375 times 4 is 5.5. 5.5 x to the 0.45 times y to the negative 0.45. And then I also have the equation 3 is still true. That's just not necessary right now. Now, this might look terrifying, but there's hope. The hope is that powers of x if I multiply both sides by x to the 0.55 and powers and y, then I get 5.625 times, so if I multiply both sides by y to the 0.45, I get times to the y there, and I get 5.5, multiply both sides by x to the 0.55, and I get just x. Well, look right there, isn't that nice? So then, solving for one of them, let's do 5.625 divided by 5.5, and I get an awful repeating decimal, because fraction-wise, these guys are, that's just 11 over 2, 5.625 times 8, 45 over 8. So 45 over 8y equals 11 over 2x. So that means that multiplying both sides by 2 over 11, and you get 45 divided by 4 times 11 is 44. 45 over 44y equals x. Well, well, well. In that case, we can substitute for x and put in this 45 over 44y. So then 40, that means 40 times 45 over 44y plus 50y equals 500,000, which means that y is going to equal 500,000 divided by all the things that you're multiplying by y. So divided by 40 times 45 over 44 plus 50. All right. So then, getting out our handy dandy calculator, 500,000 divided by 40 times 45 divided by 44 plus 50 in parentheses. Y is 5,500. Wait, I think I read that wrong. Yes, I did 5,500. Okay. Well, let's put that back into our constraint then. So then, to solve for, well, x is just that times 45 over 44. So then, take that number times 45 divided by 44, and x is 5625. Okay, so going back to our equation up here, so we're going to take the original f, take the original f right here. We're going to plug in three numbers, three points to it. We're going to do the solution we got, which is 5625 and 5500. 5625 and 5500, as well as the endpoints of g, which would be when x is 0, then 500,000 divided by 50 would be what, 10,000? And then similarly, if y is 0, then 12,500. Yeah, you don't, comma makes it confusing. 10,000. Yeah. Okay. So we'll plug in these three numbers, and it's pretty easy to see that uh, these numbers would give me 0 because you plug in, if x is 0, the whole thing's 0. If y is 0, the whole thing's 0. That means this is my maximum. Whatever it is when I plug it in. Well, let's just plug it in for fun. All right, so I take my original function, 2.5 times x is 5625. 5625 to the power of 0.45, and then times 5500 the power of 0.55. I get 13,889.75. So max 13,889.75. And there's my answer.